this episode, we are going to make sensitive data feel concrete, because AI systems have a way of pulling sensitive information into places it was never meant to go. New learners often assume sensitive data risk is only about hackers stealing databases. But with AI, sensitive data risk also includes everyday misuse, accidental sharing, and surprising leakage through outputs, logs, and integrations. The title gives us 4 categories to understand and manage: personally identifiable information, PII, protected health information, PHI, secrets, and proprietary content. Each category matters for a different reason, but they share a common truth. Once sensitive data spreads, it is hard to put back in the bottle. Managing these risks is about preventing collection you do not need, limiting exposure when collection is necessary, and building controls that catch mistakes early. We will talk about what each category means in plain language, why AI systems are uniquely risky for them, and what practical mitigations look like at a high level without turning into configuration steps. By the end, you should be able to recognize sensitive data in real situations and explain how a responsible AI program keeps it from being used, stored, or revealed in unsafe ways. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Let's start with PII, because it is the category people have heard before, but they often misunderstand what counts. PII is information that can identify a person directly or indirectly, and that indirect part is important. A name and an address are obvious, but so are account numbers, government identifiers, and unique device identifiers. Less obvious is that combinations of details can identify someone even if each detail alone seems harmless, like a job title, a location, and a specific event description. In AI systems, PII can show up in user prompts, in documents used for retrieval, in chat transcripts, and in logs used for monitoring and improvement. It can also show up in the system's outputs if the model repeats something it saw or reconstructs details from context. Beginners often think PII is only a compliance category, but it is also a trust category because people experience harm when identifying details are exposed or misused. Managing PII risk requires both privacy discipline and security discipline because you need to control who can access it and how it can be used. When you treat PII as something that can appear in unexpected places, you design systems that are resilient to human mistakes. PHI is similar to PII in that it can identify people, but it is more sensitive because it relates to health and medical information. PHI can include diagnoses, treatments, test results, prescriptions, and even contextual details that imply health conditions. It is also sensitive because health information can lead to discrimination, stigma, and deep personal harm if exposed. AI adds risk here because health-related prompts often contain personal narratives, and people may overshare because the interaction feels conversational and supportive. An AI system used in a health context might also handle data from clinical systems, which can include large volumes of sensitive content. Even outside healthcare, employees and customers may mention medical issues and support requests, human resources discussions, or accommodation requests, and those mentions can become part of datasets if not controlled. Managing PHI means being extremely cautious about collection, retention, and sharing, and it often means strict boundaries on how the AI system can be used. Another key idea is that a system does not have to be labeled medical to encounter PHI. It can appear anywhere people talk about real life. That is why sensitive data management must be proactive rather than reactive. Secrets are a different category because they are about access and control, not identity, and they are often the fastest path to a security incident. Secrets include passwords, tokens, cryptographic keys, private certificates, internal credentials, and any value that grants access to systems. Beginners sometimes treat secrets as a technical detail that only engineers care about, but secrets are one of the most practical risk categories to understand because they are frequently shared accidentally. In an AI context, a user might paste a configuration snippet, a system might ingest internal documentation that contains credentials, or a transcript might capture sensitive values that were never meant to be stored. AI systems can also produce code or instructions, and users might include secrets when asking for debugging help. The danger is that secrets can be copied into logs, stored by vendors, or exposed to other users if access boundaries are weak. Managing secret risk is about prevention, such as discouraging sharing and controlling ingestion, and about containment, such as detecting and removing secrets if they appear. The main beginner takeaway is that secrets should never be treated as ordinary text, because secrets are keys to the kingdom. When secrets leak, the consequences can be immediate and severe. Proprietary content is another category that beginners often underestimate because it does not feel personal in the way PII or PHI does. Proprietary content includes trade secrets, internal business plans, product designs, source code, financial forecasts, customer lists, and other information that gives an organization an advantage. It can also include confidential contracts, negotiation positions, and internal investigation notes. AI systems raise proprietary content risk because they encourage people to paste documents for summarization, comparison, or drafting, and that can move sensitive business knowledge into places where it is not properly controlled. Proprietary content can also be used to train or tune models if governance is weak, which can create long-term exposure if the system later reproduces or paraphrases confidential information. Even if the model does not reproduce text word for word, the risk is that insights or patterns leak into outputs that reach unintended audiences. Managing proprietary content risk is about setting boundaries on what can be used with AI, controlling where that content is stored, and ensuring vendors cannot reuse it without explicit agreement. It is also about respecting intellectual property and confidentiality obligations, which ties proprietary protection to legal and contractual risk. For beginners, the key is realizing that business harm can be as serious as personal harm, and both must be managed. Now that we have the 4 categories, we can talk about why AI creates unique risk pathways compared to traditional systems. One pathway is conversational input, where users provide free-form text that can contain anything, including sensitive data, and the system may store it for quality or debugging. Another pathway is retrieval from internal sources, where the system can pull relevant documents and then expose parts of them in outputs, sometimes more broadly than intended. A third pathway is logging and telemetry, where input and output data is captured to monitor performance, detect abuse, or troubleshoot issues, and those logs can become a hidden repository of sensitive content. A fourth pathway is integration, where AI connects to other services and systems, and sensitive data can flow across boundaries that were not designed for it. A fifth pathway is model behavior itself, such as memorization or regurgitation, where a model might repeat sensitive content it has seen, especially if it was trained on data that should have been protected. Beginners should remember that AI expands where data can travel because it is often built to be flexible and connected. When you manage sensitive data risks, you are really managing these pathways, not just the data categories in isolation. A practical first step in managing sensitive data is classification, meaning you decide what counts as sensitive in your context and how it should be handled. Classification is not just labeling. It is the start of rules about where data is allowed to go. If something is PHI, maybe it cannot be used in certain tools at all, or maybe it requires stronger controls and explicit approval. If something is a secret, it should be blocked from entry and stripped if detected. If something is proprietary, it might be allowed only in controlled environments with strict access and retention limits. Beginners sometimes think classification requires perfect knowledge, but it can begin with simple categories and improve over time. The important part is that the categories lead to consistent behavior, such as preventing sensitive data from being used for training and limiting retention. Classification also supports training because people need a simple way to recognize what they should not share. If classification is vague, people will guess, and guessing creates risk. Clear classification is the foundation for meaningful minimization. Minimization is one of the strongest protections for sensitive data, because the safest sensitive data is the data you never collect or store. If a system does not need PII to do its job, then collecting it only increases risk with little benefit. If a feature can work with partial information, you should avoid capturing the full details. Minimization also applies to retention, meaning sensitive data should not be stored longer than needed, and in many cases it should not be stored at all. Another minimization concept is exposure minimization, meaning only a small set of people and systems should access sensitive content, and those accesses should be controlled and monitored. With AI, minimization often involves designing user interactions that discourage oversharing and designing workflows that reduce the temptation to paste entire documents. Beginners sometimes think minimization will make systems less helpful, but it can actually improve safety and trust, which makes systems more usable in the long term. Minimization is also a simple principle to remember under pressure. If you do not need it, do not collect it, and if you must collect it, keep it contained. That principle applies to all four categories we are discussing. Another important control idea is separating use cases, because not every AI system should be allowed to handle every type of content. A system that helps draft marketing copy should not be the same system that processes internal legal documents, and it should not have access to the same data. Separation reduces blast radius, meaning if something goes wrong, the harm is limited. Separation also makes access control clearer, because you can restrict sensitive workflows to approved groups. For secrets, separation might mean keeping any debugging assistance away from production credentials. For PHI, separation might mean restricting health-related data to environments designed for that sensitivity. For proprietary content, separation might mean using systems where data does not leave the organization or where contracts prohibit reuse. Beginners can think of separation as building rooms in a house rather than living in one open warehouse. When everything is connected to everything, sensitive data risk becomes unmanageable. When you create boundaries, you can control data flow more reliably. Detection and response are also part of managing sensitive data, because even with strong prevention, people make mistakes and systems misbehave. Detection means noticing when sensitive data appears where it should not, such as secrets in prompts, PII in logs, or proprietary content in outputs. Response means having a plan for what to do next, like containing access, removing data, rotating secrets, notifying stakeholders, and documenting the incident. Beginners often assume that if sensitive data leaks, the damage is done and nothing can help, but good response can still reduce harm. For example, rotating a leaked secret can cut off unauthorized access quickly, and removing sensitive logs can reduce exposure. Another key point is that response should be rehearsed, because sensitive data incidents create urgency, and urgency can lead to poor choices. Managing sensitive data risk is therefore a lifecycle practice. You prevent where possible, detect where necessary, and respond when issues arise. When detection and response are integrated into normal operations, sensitive data risk becomes manageable rather than terrifying. A misconception worth correcting is the idea that sensitive data risks are only technical problems to solve with security tools. Human behavior is often the biggest driver, especially when AI systems feel like helpful assistants. People may share more than they should, trust the system too much, and forget that their input can be stored or reviewed. That is why training, clear policies, and user experience design are part of sensitive data management. Another misconception is that if a vendor provides the AI system, the vendor owns the risk, but your organization is still responsible for protecting customer and employee information and for honoring confidentiality commitments. Another misconception is that hiding names removes risk, when in reality context can still reveal identity and sensitive content can still harm. The better mindset is to treat sensitive data as something that must be controlled by design, not cleaned up after the fact. When you build systems that assume mistakes will happen and that control must be robust, you create a safer environment for everyone. Sensitive data management is therefore not about mistrust of people. It is about realistic design for imperfect humans. As we close, managing sensitive data risks in AI systems is about understanding what kinds of information can cause serious harm and building controls that keep that information from spreading. PII is about identity and the ability to link data to a person. PHI is about health and deeply sensitive personal context. Secrets are about access and the ability to compromise systems, and proprietary content is about confidential business knowledge and competitive harm. AI makes these risks more complex because data can enter through free-form inputs, be stored in logs, be reused for improvement, or be exposed through retrieval and outputs. The strongest protections begin with minimization and clear boundaries, supported by classification, separation of use cases, access controls, and disciplined retention. Detection and response matter because mistakes and unexpected behavior are inevitable, so you need ways to catch problems early and contain harm. For brand new learners, the key takeaway is that sensitive data is not just a compliance topic, it is a real safety topic. If you can recognize these categories and understand why AI systems amplify exposure, you are well on your way to making safer decisions throughout the life cycle.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.